Good morning, everyone. My name is Kenneth Ng, the Sales Manager for the OEM and System Integrator teams at Host. I bid you a very warm welcome to our webinars on the topic of the evolution of the modern factory. As the manufacturing industry shifts to Industry 4.0, there is a demand for efficiency and sustainability. End users and OEMs are adapting and adopting smart machines and processes to achieve efficient utilization of energies and materials. We need to effect change now, as the global market is evolving and manufacturers need flexibility to design changes on a whim to push their products out quickly to keep up with the demand. Today, we are delighted to have with us three speakers. Mr. Max Chia from Rockwell, who will introduce Rockwell Independent Cart Technologies. Mr. Kelvin Lai, also from Rockwell, who will talk about smart machines and how they can help you boost your productivities. And last but not least, Mrs. Nico from Host, who will speak of the application of the use of automatic mobile robots, or AMR, and collaborative robots. Now, before we begin, please allow me to introduce Host and our suite of solutions.
3 decades of experience in industrial automation has made Host, part of Sonepar Group, the trusted and leading partner of companies looking for holistic solutions to their industrial needs. Businesses like yours no longer need to rely on expensive and cumbersome manual processes. With our cutting-edge solutions on carbon footprint reduction, energy management, production and operation, smart manufacturing, robotics, network, cybersecurity, and we deliver customer-centric value to address evolving business needs. Get work done quickly. Contact us today.
Established since 1979, Host have transformed into a solution provider, focusing on innovative and sustainable automation solutions to the market. In 2014, we joined Sonepar Group. Sonepar has been the industrial automation and electrical product distributors for over 50 years, with 48,000 associates worldwide and 145 operating companies in 48 countries. In 2019, our group sales achieved a total of 24 billion euros. Our mission at Host is to embrace technologies with our ecosystem partners to deliver the best-in-class customer experience and satisfaction through our employees. We believe in continual engagement with our customers and hence provide regular trainings, workshops, and technical support. Over the past year, Host has mapped the following initiatives. Starting from the bottom left, we are focusing on carbon footprint reduction and reducing energy by delivering high-efficiency solutions. 2. Through energy management solution, we engage in technologies to better manage energy system. 3. With production and operation, we help customers to increase uptime and to reduce downtime. 4. Through smart manufacturing, we use results from data analytics to better plan manufacturing. 5th, we use network to connect systems through network design. And last, we ensure cybersecurity by providing network threat detection solutions and address on critical assets and infrastructure, ensuring plants' high availability. Our focused product portfolio presented here address our initiative and allow hosts to venture into new space and to cooperate with different technological partners. We add value to our end user by providing comprehensive solutions professionally. With this, I thank you for your attention and would now pass the time over to Mr. Max Kia.
Everyone, I'm Max from Rockwell Automation, representing the Independent Cart Technology Business Unit. With the ever-evolving needs from the manufacturing environment, new rules and trends leads to smart and flexible manufacturing. With consumer demands like myself and you, more information on nutritious value, health, ethics, allergy warning has been clearly labeled on the packaging. Therefore, it leads to customization and in turn create multivariant packaging of the same product, which create more packaging SKU. And manufacturers are struggling to keep up with the changes as the number of increased SKU is projected at 10 to 50%. With the shrinking labor workforce for manufacturing, time to fill out a trained and skilled technician takes roughly about 70 to 120 days. With this general trend, let's see what challenges is in the manufacturing environment. Now let's look at the trend, challenges and concerns from end user viewpoint. Under operation, we have high product mix causing numerous setup changes causing lost production time, high maintenance costs on belt and chain system when running at full speed as the maintenance intervals get shorter, inventory pressure as you need to keep numerous mechanical parts to keep the belt and chain system running, high energy costs, and plant floor space constraint. We look at the technology segment, speed limitation with the current conveying system, and newer complicated packaging require different motion profile or assembly technique to achieve the final packaging. Last but not least, we look at the profitability of the plant. With mass customization, it means dipping into your bottom line. Machine design and manufacturing flexibility. Let's look at higher production rate, simpler mechanics and pitchless control. Machines that have to run multiple sizes such as 4, 12 and 16-inch carton must be sized for the largest carton, making smaller carton run less efficient. ICT gives freedom of pitch, allow for optimization design to maximize speed regardless of the size. We eliminate chain, belt, gearbox and other mechanics that can limit speed. Faster changeover. With number of changeover continue to increase, fast and consistent changeover can have an even greater effect on overall production that a machine can achieve. Reduction in in-feed complexity. Traditional machines require product to be orientated, spaced, and tiny precise to function properly. This drives in-feed complexity. ICT provide flexibility that allow for simpler in-feed with spacing and timing inherently handled by the ICT technology. The individual tools on the mover can stay the same for various SKU. Any changes for pitch or spacing are done electronically and require no physical change. Supporting one button changeover, function associated with ICT technology can be changed digitally with no needs to interact with the machine mechanics. Shorter machine shutdown required because ICT related changes can be done digitally and are virtually instant. Flexibility of ICT also means that it's easier to automate other changeover points on the machine throughout optimization of design. With the accuracy of digital change of the ICT system, not only is the changeover faster, but efficient production is possible right away at the restart. Product to be precisely spaced coming into the machine, no smart belt or complicated transfer. Improve operational efficiency and reliability, mix of continuous and intermittent motion. The process being carried out within the machine can be optimized, utilizing whatever motion is most efficient for the production sequence. Reduce force space and manpower. Function performed by multiple machines can now be integrated into a single platform, which make integration of the turnkey solution easier. Manufacturing flexibility. Format change on the fly can optimize performance based on the package being run. Simple tooling change and programming can allow for reconfiguration to a new packaging or function. High scalability can easily redeploy for new product because it's not limited to what the machine was designed for production. Possible capital saving by reuse or redeploy the equipment across a broader array of applications. And we also have a modular machine approach, which with the use of robots and their flexibility, it's easier to design the rest of the function of the machine to be modular and changeable. The end user can utilize much of the existing asset versus a whole new capital investment. Historically, motion control has incorporated chain, belt, gear, and other mechanics, and this indirect solution have limited flexibility, waste energy, and excessive maintenance costs. So with ICT, we can achieve a higher throughput with fewer mechanical components and linkage. We can achieve a higher acceleration of 10G and also a speed of up to 5 meters per second. And it's combined with fully controlled motion profile for higher throughput. Unlimited flexibility. Each moving cut is controlled independently, allowing for flexible mechanical pitch, enabling the same machine to handle multiple package format size at once and fully controlling product motion. Constant package tracking. Integrated track and trace software control card with precise knowledge of the card position eliminates needs for external sensing and complex tracking solution. Increase uptime. Elimination of mechanical linkage and component allows minimum number of moving parts, reduce overall downtime, maintenance, and energy consumption. Smaller footprint. Technology allows to combine all product format in one machine type within a smaller footprint. Let's look at the independent cart technology portfolio. We have the mover light, which is an intelligent conveying system for payload lighter than 10 kg. It's easy to design and set up, flexible, modular, and scalable, simple programming, and can control up to 1,000 carts within a large system. And next we have the quick stick and quick stick high thrust. They are intelligent propulsion and control system, can have payload from 10 to thousands of kg. It's flexible and modular and scalable. And same like the mover light, it can have up to thousands of vehicles in a large system. So for iTrack, it's an intelligent positioning system. It's a closed-loop performance LMS, and you can synchronize with other motion axes within the production area, and it's high dynamic performance and force. High thrust. It's more favorable with system integrator and end user, and many wins for between machine transportation and station to station transportation for assembly operation. It's able to do multi-lane layout, and switching is a major differentiator. Sync motion is gaining popularity to synchronization with external auxiliary equipment outside the system. For iTrack, it's favored by OEMs Machine builders, many wins for high payload and high speed application, build the core of machine and require completely new machine design. C-level approach, mechanical and electrical engineering, and mainly used in packaging and manufacturing and assembly application. All this product is scalable and modular and is flexible. Importantly is that these are controlled with what we call the fire and forget control programming, and you can do a merge, diverge, transversal with complex path system on a large scale transport design, and mainly is controlled via ABPLC over the Ethernet IP and control over TCP IP, and these are using the same common software platform for the magnetic motion product family. We have the iTrack medium frame where you can have a peak force of up to 793 Newton and is perfectly fit for higher payload application. We also have what we call the iTrack ETO, where you can have liquid cooled motor modules, heavier payload movers, and large radial curve. Control style. The standard control for magnetic motion is like a taxi services or what we call fire and forget. We just issue a command to a vehicle to move to any point in the magnetic motion system. The control system will drive the vehicle to the final destination at a max velocity and acceleration. And this control system generates a motion profile, adjusts it as necessary for vehicle to arrive to its destination. As mentioned, collision avoidance is actually a standard feature within the fire and forget control. And we have another type of control, what we call the Singlet Control. It's as good as like driving the car. That means it complements means to control the motion of vehicle, quick stick or magnetic motion or iTrack. You can determine the acceleration, the speed, and where it moves, and where is the sync zone. That means where you need to synchronize with external auxiliary equipment. So this is the two types of control that is available for the ICT family. Now let's view an application video of horizontal form fill and seal, whereby it utilizes the easy changeover using a one-touch button. So everything is changed automatically and very fast. That's the end of the application video. As you can see, that it illustrates the fast changeover and how easy it is to do it with a touch of a recipe control. Thank you for your attention. Now I'd like to pass it on to the next speaker, Mr. Kevin. Thank you.
Thank you, Max. Hi, everyone. I'm happy you can join the session today. My name is 𝐿𝐕𝐿𝐼, and I'm an architecture and software lead from Robot Automation. In this presentation, I'll be sharing with you what are smart machines. I would like to draw a consumer product analogy when it comes to smart things. Fitness tracker, they are example of smart devices. Based on your experience with this device, it's not raw data like you see here. From this information, could you really make better decisions? It's pretty hard to find something meaningful in that data, I believe. So, making the data more descriptive with simple transformation or charting might help a little, but even in this state, it won't really meet the needs of average consumer. Plotting against time, you can see when you are active, but if this is all activity tracker app provide you, I would say you'll be pretty disappointed. So, what you really want is something like this. Information group and summarize, key indicator visualize, and exceptional shows. This view uses the same data, but analytics transform the data into something that you can really easily glance and understand. So, how does this apply to industrial automation? There's an evolution underway of converting components into intelligent connected devices. And these devices are being integrated into broader systems that are radically changing the competitive landscape for everyone. It is also creating new workflow tools to allow workers to be more collaborative, agile, and efficient. Digitalization is about bringing the machine closer to people with things like augmented reality, where we can use mobile devices like our phones or glasses that provide contextual and actionable information in real time. Technology that can be used to train operators or augmented field technicians as they diagnose, troubleshoot, and repair products in the field. Based on some statistics, it is predicted that by 2025, IoT will contribute a cumulative increase to the world economy of between $5 to $11 trillion. So what is a smart machine? It's about turning data into action in real time. This intangible commodity is the key to better understanding of their operational performance at the most gradual level, so they can improve operations and produce more at higher quality levels in a more efficient manner. A smart machine also solves challenges created by pressures and trends that are faced by end users today, such as provide unprecedented access to real-time data that can be turned into actionable information. Data can be logged and analyzed to help workers make better decisions and ultimately optimize not only the equipment, but the manufacturing process itself. These capabilities are creating new opportunities for organizations to achieve faster and more productive processes, produce higher quality products at lower cost, increase productivity, and also more optimizing supply chain. So, building smart machine requires the right mix of technology, process, and people. What are the key business drivers for OEMs to build smart machine? Firstly, I would say it add values, and then it also reduce costs, it create new revenue streams, and also reduce risk. Building a smart machine will bring positive impact to your business. So don't wait, start identifying opportunities. Building a smart machine is a journey, so start small while building up a roadmap to reach the ultimate goals. Thank you everyone, this is the end of my presentation. There will be 3 poll questions before I pass the presentation to Nicole, host solution sales consultant, which will be talking on the robotic solution.
Hello everyone, welcome to the robotics session. I'm Nicole, the solution sales consultant here at 𝐉𝐢𝐦𝐞. I've spent a half decade in automation industry with a focus on robotics. Today, we will be looking at the following: 𝐼𝐦𝐻𝐭 Cobot and 𝐼𝐻, the 𝐼𝐻 industry robot. We will be running a live Q&A at the end of this webinar, so if you have any questions, just pop in here. Let's start with the mobile industry robot. What is the difference between AMI and AGV? A guided vehicle follows the fixed routes, usually along wires or magnetics embedded in the ground. An AGV robot is probably clever enough to use simple sensors in order to avoid hitting obstacles along the way, but it's not clever enough to go around them. Whereas AMI is much more sophisticated, it's packed with sensors, and it's powerful onboard computers that helps it to understand its operation environment. An explosion in the number of mobile robots in use in 2020. A growth of 333% in manufacturing industry and 798% in the healthcare sector. This research result is done by the International Federation of Robotics. Different industries have its different needs, so every industry faces unique challenges, but across all types of sectors. AMI can add value to make your business work more efficiently, smarter, and safe than before. 𝐼𝐻 is an open robot ready for your application to be integrated. With the 𝐼𝐻 we present some of the applications that are ready to go. Easy plug and play. Here you can see different categories and specific products and solutions made by third party for the customization of the 𝐼𝐻 robot in order to meet customers' needs. You'll also be able to ask for documentations you need to make your application through 𝐼𝐻. So, 𝐼𝐻 UI is an extremely user-friendly interface, works on PC, tablets, smartphone, and the dashboard is customizable. So, the 𝐼𝐻 fleet also offers a centralized control of the robot from a single station throughout your facilities. And thanks to the intuitive web-based interface, it's easy to program and control a robot fleet, including the robot with a different top modules, hooks, and other accessories. Once the programming phase is over, the system manages the prioritize and selects the most suitable robots to the operation that needs to be carried out, based on positioning and also availability. And also you will be also able to receive email notifications, keep you updated about obstacles or other possible unforeseen events that may prevent the robot from carrying out a task. Here is the market analysis. 𝐼𝐻 has an advantage over the other AGV or AMRs. Our 𝐼𝐻 has a friendly user interface, easy to operate and program, and do not require a high engineering cost for the deployment. And there's no additional cost for laying out track or magnetic tapes. And it's lesser idle time, longer battery running hours, which is up to 10 hours time. And the speed limit range is from 1.1 to 2 meters per second. Our 𝐼𝐻 uses lithium battery, which is more compact. It has a 24 watt for 𝐼𝐻 100 to 200, 48 watt for 𝐼𝐻 250 to 𝐼𝐻 1000. The charging time is 3 hours for 24 watt and 1 hour for 48 watt supply. It's smaller in sizes and requires less space for parking and charging. So, about the sensors, let me bring you to more details. Here are the sensors for safety. There are two types of sensors mainly used for navigation and obstacle avoidance. The 3D camera shown in figure 1.1 is used for frontal obstacle avoidance, and the camera does not record live video but power counts. It detects obstacle in front from 5 cm above the floor to 1.8 meters high. And our laser scanners, each with 27-degree coverage, and there are 2 in each corners of the robot, which covers total of 360 degrees around the robot, 2-meter emergency zone, and 8-meter warning protective field range. The laser scanner is also used for mapping, plan routes, and localizations. Other than that, there are ultrasonic sensors, internal sensors including RMU, motor encoder, accelerometers. And this is what the robot will see in a real-life example. Figure 1.1 shows that what human eye sees, a chair in the corner of the room, and Figure 1.2 shows that what the mirror sees in front of using the front camera, a cloud or dot of objects above the map. And Figure 1.3 is that the mirror sees with the laser scanners, a red dots fitting on top of the black lines of the map. Let me show you some case studies for mirror application. Infinix specializes in R&D and manufacture of Chinese herbal supplements. There are total 3 MIR 200 robots were deployed in the oral liquid production workshop in the Jiangmen plant. Allows users to optimize human resource allocation and maintain a well-balanced workflow in terms of the traffic and productivity. And New Form, which is a world-leading manufacturer of Italian design tapes and fittings. The MIR robots are used in the internal logistics, and cobots are now handling the main parts of the covering between departments. In the result of time and production optimizations, lines are active on a 24/7 basis. Let me show you a video before we move on to Hanwha cobots. Here you go. What is a collaboration robot? Cobots are robots intended for direct human-robot interaction with a shared space, or where humans and robots are in close proximity. Automation is no longer difficult. The collaboration robot, Hanwha, is easy to control and is flexible in responding to the changes in the production layout, efficiently cutting investment costs and also the operating expenses. It also provides a safe and convenient work environment. There are total 3 types and classified as 3 kg, 5 kg, and 12 kg payload. The CR3 3 kg payload with an infinite rotation on the end joint has an advantage of screw driving and ensemble applications. 𝐻CR5 has its range of 915 mm, helps the employee to improve the productivity, and it is also clean room class ISO 2 certified. For 𝐻CR12, it is with a larger working radius, easy to pick and place for heavier load. Hanwha robot is easy to program and operation. You may see here, it can be easily programmed by using its icon-based graphic user interface. And the timeline-basis programming allows the user to intuitively monitor the workflow. In a more simple way, user is able to grab the robot and direct teach the waypoint or record the motion path to the robot. You may look at the video here. Here is the case study for screw fastening. It uses a 𝐻CR3 or 5, solve the challenge in fastening quality, risk in missing screws, flexibility against the model changes. Its easy program helps respond against the fasten angles and frequent job changes. You can look at example here. This is another case study for 𝐅𝐚𝐜𝐬𝐧. It uses a 𝐻CR5 with a welding gun and feeder, and this overcomes the challenge in operator safety, high accuracy, repeatability. The operator will decide the start and end point by direct teaching. 𝐻CR12 with a dual gripper is used for CNC machine tending. This case study overcomes the challenge in manpower shortage, the short product life cycle, and also the tight working space. And this will be my last slide. There will be 2 poll questions. Please feel free to share your thoughts. Thank you.
I would like to thank all the speakers. I hope everyone have discovered something useful for your future application. We have come to the last segment of our webinar, the Q&A. You may post your question in the chat box on the bottom right, and we will get the speakers to answer them. Due to the time limit, any unanswered question will be attended to via email. Thank you. That can apply in the technology for the magnet motion or eye track. This question, may Max answer it?
So as mentioned in the presentation, is that magnet motion is mainly used for transportation between machine, and eye track will be mainly used in the in-machine application.
All right, thank you. Probably there's another question related to Max. What is the difference between magnet motion and eye tracks?
I think one thing is that if you look at it this way, magnet motion is more of a general usage, and I would say that the precision level is different from what the eye track can do, and eye track is more of a high dynamic and high performance system.
All right, thank you, Max. Okay, next from the audience, we have a question probably from Nicole. I have a concern on overhanging objects. Hosts to provide solution to address the solution. Nicole? Sorry, Nicole, can you repeat your answer? It's not captured.
We are able to recognize any overhanging object from 5 cm above the ground all the way to 1.8 meters height. So any object in between can be recognized and avoid when the mirror is traveling along.
All right. Thank you, Nicole. Okay, I'll have the last question to Kelvin. Kelvin, this question is for you. The audience have this question. I have a current machine in the plant. How can I make it to be smart? Yes, Kelvin?
Yeah. Okay. So in terms if you do have equipments inside and you want to do some improvement itself, we can always see what is the ultimate goal that you want to achieve with it, like maybe adding more sensors to your current equipments to just get all the respective information out to make it more smarter. And the other thing to be looking into is also on your current equipments itself, what are the informations available. Then we can work on that to actually build the machines to be smarter if you do have an existing machine.
Okay, thanks, Kelvin. Due to the time limit, any unanswered question, we will send the answer via email to the respective audience. So lastly, I would like to thank all the audience for having your time to join this webinar. Thank you.